Okay, so thank you for coming back after that last previous segment. So I realized that that probably scared a lot of you off, but remember, if you're one of my students, don't worry about those equations of stellar structure. I just want you to know, how do we know that the sun has these different things inside of it? So now let's talk about the actual structure of the sun. We're going to start with the core. So in the core, that's where the nuclear explosions are taking place. So this is where hydrogen is being converted into helium. This is the area of the sun which has a temperature of about 15 million Kelvin. Okay, then on the, now, as we're going from the core to the surface, the temperature is going down. Because after all, in outer space, the temperature of outer space is like about 4 Kelvin. So that must mean that the temperature is going down as you're going from the inner core to the surface of the sun. So as we're going further away from the core, the temperature is dropping. Now, once the temperature drops below 10 million Kelvin, that's a magic number that you should know. So once the temperature drops below 10 million Kelvin, there's not enough energy to slam those hydrogens together and turn them into helium, okay? So that once you get out of the core, there's no more nuclear fusion going on, okay? But it's still very, very hot. It's so hot that atoms cannot exist. So an atom has its nucleus, and then it's surrounded by its electrons. If it gets too hot, those electrons have so much energy that they pop off. And then you have an ionized gas or a plasma. So in this part of the sun, it's still so hot that there are no atoms. So what you have is a bunch of hydrogen nucleuses and helium nucleuses running around and bumping into each other, but they don't have enough energy to fuse. Now, this energy is trying to make its way to the surface. So heat always travels from hot to cold. It's cold in outer space, it's hot in the core, so that this energy is traveling to the surface. And it turns out that the best way, the most efficient way for this energy to travel is in the form of radiation. So do you remember that there were 3 ways that heat traveled? Remember? Duction, convection, and then radiation. So in this particular part of the sun, the best way for the heat to travel is in the form of radiation, in the form of light, mainly X-rays and gamma rays. Okay, now let's go into the next layer of the sun, which is going to be called the convection zone. So we're going from the radiation zone to the convection zone. And in the convection zone, it's cooler. Okay, it's continuing to get cooler and cooler. So in the convective zone, what happens is it's cool enough that some of the electrons start to reattach to the atoms. Not all of them, but some of them. So some of the atoms are now going to be partially ionized. So some of the atoms have electrons attached to them. And now once they've got electrons attached to them, then it turns out that the best way for them to be able to move is in the form of convection. So convection is, remember that the inside of the Earth is convecting, that the heat travels from the core to the crust of the Earth, and it made these circle things. That was called a convection pattern. And then the atmosphere does the same thing, and then this is how we make clouds. So inside the sun, it also convects. So we're going to call that the convection zone. Now, when we get to the photosphere, okay, that's going to be this very thin surface of the sun. So don't look at the sun, But if you were to look at the sun, it would look yellow. And that yellow ball that you're seeing is the photosphere, the surface of the sun. And now when you look at the photosphere, the temperature has now dropped to the point at which all of the electrons have attached. So now in the photosphere you have atoms that make up the photosphere. And what do we know about what electrons do? If you have an atom and it had different levels of electrons, do you remember that the electrons could jump up and absorb energy, and when they came back down they would emit energy? Well, they would emit energy in the form of visible light. So that's the reason why you can see the photosphere, is because it's now composed of atoms that have electrons that are jumping up and down. Okay, now let's go, also we're going to talk about this in the next video, but the surface of the sun is what we call granulated. So just keep that in mind. Now we're going to go to what's referred to as the atmosphere of the sun. Now that kind of makes it seem like the sun is solid like the earth, and then it has an atmosphere like the earth does. Well, it's just kind of convenient to talk about it that way. But really, the sun, the inner part of the sun is a plasma, and then the outer part of the sun is turned into a gas, the photosphere, and then the corona and the chromosphere are both going to be gases. So when you get up there. So the chromosphere is the next layer that you come to. It's very thin, not in terms of distance. It's very large in terms of its radius. So the radius of the chromosphere is very large. So when I say it's thin, I mean its density. So the density of the gas particles that makes up the corona is very thin. And it's also very cool. Because the further away from the sun you get, the cooler it gets. But when you get to the next layer, which is the corona, so the chromosphere was the thin, cool part of the sun. And then when you get to the corona, it's also going to be thin as far as its density is concerned. But it's going to be very hot because of the sun's magnetic field helps to hold in energy. And so that's the reason why that part of the sun is very hot. And then that tapers off and turns into the solar wind, which is going to be kind of like the debris that is being blown off of the sun, which is going to be in the form of electromagnetic radiation, and then some protons, and then some electrons make up the solar wind. So those are the various parts of the sun. Now, I did also want to mention, you can see the chromosphere and the corona under special conditions. So during an eclipse, when the moon gets in front of the yellow part of the sun, then you'll see this pearly looking color that surrounds the sun, and that is going to be the corona and the chromosphere. So you can see it during a solar eclipse. But don't try to look for it during an ordinary day because you blind yourself. It's there, it's just that the sun is so much brighter that you cannot see it. Okay, in our next segment, we're going to talk about what does granulation